In this video, we're going to discuss how you can switch a quadratic equation from standard form, y is equal to ax squared plus bx plus c, to vertex form, y is equal to x minus h squared plus k. Let's look at an example. Y is equal to x squared minus 6x plus 5. And we're going to switch this into vertex form by completing the square. Whenever you're completing the square, the first thing you want to do is have all the constants on one side and the x squared and the x on the other side. Usually when we're solving an equation by completing the square, we set y equal to 0 because we're solving for the x-intercepts. Here we're not solving for x-intercepts, so we're just leaving y how it is, ignoring the y. So minus 5 and minus 5 to bring it over to the left-hand side. Y minus 5 is equal to x squared minus 6x, and the plus 5 and minus 5 cancel out. Now we want to find some way to make the x squared minus 6x, that side of the equation, into a perfect square polynomial. A perfect square polynomial, you might remember, is when we're multiplying the same two factors by each other. Let's say it would be x plus 5 times x plus 5. When FOILed out, this would be a perfect square polynomial. In order to make x squared minus 6x into a perfect square polynomial, we're going to take 1/2 of b. b is always the coefficient of the x term. So we're going to take 1/2 of negative 6, and we're going to square that value. 1/2 of negative 6 is negative 3. We're going to square negative 3, we get 9. So we're going to add 9, add that value to both sides of the equation, plus 9 and plus 9. So on the left-hand side we have y. Negative 5 plus 9 is positive 4, is equal to x squared minus 6x plus 9. Now we're going to factor the right-hand side. We just made it into a perfect square polynomial. We need to find factors of positive 9 that add up to negative 6, and we know that they're going to be two of the same factors. Factors of 9 that are the same thing are either 3 and 3 or negative 3 and negative 3. Since we want the factors that will add up to negative 6, we're going to choose negative 3 and negative 3. So let's rewrite the equation. Y plus 4 is equal to x minus 3 times x minus 3. Since we have the same factor, since we have two of the same factors on the right-hand side, we can rewrite that as x minus 3 squared. So y plus 4 is equal to x minus 3 squared. Now we're going to bring the constant back, so we have our equation solved for y. Minus 4 and minus 4. Y is equal to x minus 3 squared minus 4. Notice now that this equation is in vertex form. Vertex form, you might remember. Y is equal to x minus h squared plus k. So in this case, the vertex would be whatever we have for our h value. Our h value in this case would be 3. So our vertex is 3, comma, whatever our k value is. Our k value in this case would be negative 4, because normally we have a plus k. So since here we have a minus, we have to switch the sign. And our vertex would be at 3, comma, negative 4. Let's look at one more example. Let's say we have the equation y is equal to negative x squared minus 4x minus 3, and we want to put this into vertex form by completing the square. Remember, when completing the square, your a always has to be 1. In this case, our a is negative or negative 1. To get rid of that negative 1, we can just divide everything by negative 1. Since we're dividing the right-hand side by negative 1, we also have to divide the left-hand side by negative 1. Y divided by negative 1 is just negative y. Negative y is equal to negative 1x squared divided by negative 1 is positive 1x squared, or just x squared. Negative 4x divided by negative 1 is positive 4x. Negative 3 divided by negative 1 is positive 3. Now we could start completing the square. Whenever we're completing the square, we want the constant on one side and all the x squared and the x on the other side. So minus 3 and minus 3. Negative y minus 3 is equal to x squared plus 4x. We want to make the right-hand side of the equation into a perfect square polynomial. To do that, we're going to take 1/2 of b. b is the coefficient of the x term, so in this case it's 4. 1/2 of 4 is 2, and we're going to square that value. 2 squared is 4. We're going to add that number, which is 4, to both sides of the equation. So we have negative y plus 1 is equal to x squared plus 4x plus 4. Now we're going to factor the right-hand side. We need to find factors of the c term, which is 4, that add up to the b term, which is also 4, and we already know that it's going to be 2 of the same factor because we made it into a perfect square polynomial, so that it should have 2 of the same factors. Factors of 4 that are the same thing are 2 and 2, and negative 2 and negative 2. The ones that add up to 4 are positive 2 and positive 2. So our polynomial now looks like negative y plus 1 is equal to x plus 2 times x plus 2. Since we have 2 of the same factors, we can rewrite that as x plus 2 squared. And that whole thing is equal to negative y plus 1. Now we want to bring the constant over back to the other side. So we're going to subtract 1 and subtract 1. Negative y is equal to x plus 2 squared minus 1. But now we're left with our equation solved for negative y. We want to have our equation solved for y. In vertex form, we have y is equal to x minus h squared plus k. It's solved for y. To solve it for y, we're going to divide away the negative. Divide away the negative. Y is equal to x plus 2 squared divided by negative 1 is negative x plus 2 squared. Negative 1 divided by negative 1 is positive 1. So this would be the answer to the question. This is the same equation written in vertex form, and the vertex is always h comma k. H in this case would be negative 2 because normally we have a minus h, and here we have a plus 2. So our vertex is going to be the opposite. It's negative 2, and k is always a plus something, so since in this case it's also a plus something, it's just plus 1, positive 1. And our vertex is negative 2 comma 1.